Now that we've talked about key features of functions, we actually want to use the functions in some real world situation. I'm going to ask you questions about x-intercept, y-intercept, but now they're not just points on a graph, they actually have meaning. So let's go through this first problem and see if it makes sense to you. So for each of the graphs, answer the questions. This graph models a boy's distance from home. Use it to answer the following. Well, here's the first thing I want to do. I want to look at the graph. So this shows you his distance from home. So he's 40 kilometers away from home at time 0. That's what this means. Notice this function is decreasing. So that means that he's going home. His distance away from home is getting smaller. That means he's getting closer to home. So now let's actually answer some questions here. In the point 2010, explain what each number represents. Well, my x-coordinate deals with my minutes. My y-coordinate deals with my distance. So 20 seconds, 10 kilometers. So after traveling for, 20 minutes, the boy is 10 kilometers from home. Now let's look at 0, 40. Same idea. Time 0, 40 kilometers. The boy's initial distance at time 0 is 40 km. I guess I could say he starts his journey 40 kilometers from home. That's at time 0. Give the independent and dependent quantities. Oh, dang, we're going back to Unit 1 for this one. So the independent, once you see a graph, it is always your horizontal axis. So this is independent. So the independent quantity is time. And let's go ahead and knock D out while we're at it. And we measure this, our units are in minutes. Our dependent quantity is always the vertical axis, the vertical measurement. This is our distance, and the units we measure our distance are kilometers. Now we're asking for the domain and range. So previously in domain and range, I gave you discrete points. You would have a point here, 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 name the x-coordinate. Now, however, we have a continuous graph. So I want to know where our x's go. Well, we have one x at 0, and we're going to continue along until we get to another x of 20. So for this one, it looks like we're going to go this way. We're going to go from 0 to 20. X is between 0 and 20. So physically, x is between these two numbers. Algebraically, it's between these two numbers because it's less than or equal to 20. But in the meantime, 0 is less than or equal to x. And down the road, we're going to talk about interval notation. You'll see it in Algebra 2, but I sometimes see it in Algebra 1. I really can't remember. What interval notation does is it does not even include the variable. It says we're going to go from 0 to 20. We can equal x, so we're going to put a bracket. Or we can equal 0. We can equal 20, so we're going to put a bracket there as well. Our range, remember, our range is the set of all y coordinates. So look at your y coordinates. My y coordinates go from 10 to 40. So it looks like my y value goes anywhere from 10 to 40. And in interval notation, we're going 10 to 40. Give the unit rate, the slope, with units that models the situation. So they're asking for slope, and I immediately turn to my slope formula because while I love rising and running, I prefer to do that over smaller numbers. And I honestly get mixed up with my X's and Y's all the time whenever I try to travel. So my second Y is 10. My first Y is 40. Let's divide that by my second X of 20 and my first X of 0. I'll get negative 30 divided by 2, which is negative 1.5. So the unit rate is negative 1.5 with units, kilometers per minute. So this child is traveling 1.5 kilometers per minute. Some of you will want to see the rise and run, so let's do that. So from this point to this point, we're going to go down from 40 to 10. So we go down 30. Then we're going to go to the right from 0 to 20, which means we go to the right 20. And when we look at our rise over our run, negative 30 divided by 20 is negative 3/2, which is negative 1.5. Okay, I get the same answer. I feel good. G, convert the unit rate found in F to convert miles per hour to convert 2 miles per hour. Well, dang, we're looking at unit 1 again. So let's look at 1.5 kilometers per minute. So I need to turn that into miles per hour. So let's start with the kilometers. If I have a kilometers in the numerator, I need a kilometers in the denominator for those to divide out. And I need a miles in the numerator. Is there some unit rate that equates miles to kilometers? Yeah, it's right here. So I know that 0.62 miles equals 1 kilometer. So I've taken care of my distances. Now let's look at time. I need to turn minutes into hours. So in order to remove the minutes in the numerator, I need a minutes in the denominator let me start over. To divide out the minutes in the denominator, I need a minutes in the numerator, but I also need my hours to go down here. And is there a way to equate minutes and hours? Yes. There are 60 minutes in 1 hour. So let's go ahead and carry out this multiplication. So I have negative 1.5 times 0.62 times 60, and I get negative 55.8 when I divide that by 1. Everything in the denominator is 1. So it's negative 55.8 miles per hour. Excellent. So you can see he had to have been driving because you can't walk that. Give the domain in 20 seconds. Well, our domain originally was in minutes. So we went from 0 is less than or equal to X is less than or equal to 20. To convert minutes into seconds, we have to multiply by 60. So this becomes 0 is less than or equal to X, which is less than or equal to 1200 seconds. So there's everything that we know for that graph. Just being able to answer questions. They're not just numbers anymore. They're values. They're meaningful values, I should say. Number 2, the graph shown models the amount of money saved by Pam over a period of time. Use it to answer the questions below. How much money did she start with? Well, your start value, remember, is your y-intercept. So let's go there. Well, she started with $58. And please note, the dollar symbol goes in front of the number. Kills me when I see people doing that, even grown people. I mean, daggum. How many weeks did she save money? Well, weeks are here. The weeks go from 0 to 8. So 8 weeks. Give the independent and dependent quantities, and then let's go ahead and do their units. So remember, independent is here. So time is independent. And we measure this in weeks. My dependent quantity is money saved, and it is measured in dollars. What's my domain? My domain goes from left to right. So it goes from 0 to 8. So 0 is less than x. 0 is less than or equal to x is less than or equal to 8. Again, that's how it would look as an interval. My range goes from 58 up to 180. So my range, 58 is less than or equal to y is less than or equal to 180. And this is how it looks as an interval. Give the unit rate, the slope that models this situation. All right, so my slope is going to be 180 minus 58 divided by 8 minus 0. Let's get my trusty calculator out here. 180 minus 58 is 122. And we'll divide it by 8. And I get 15.25. With units. So this is $15.25 per week that she saves. That's not bad. If Pam continues to save money at this rate, how much money will she have after 1 year? Well, show your process and your setup. My process always starts with an equation. And for this equation, I like slope-intercept form. So let's fill in what we know. I know my slope is $15 per week. I don't know the week, so we call it X. My y-intercept was my start value. Oh, that's right here. She started with $58. So there's my equation. Y is the money, and X is the number of weeks. Now, how much money will she have after a year? Well, they're asking about a year, but my equation and my graph are weeks. So it's going to help me to know that in 1 year, there are 52 weeks. So what they're really asking me to do is find y when x equals 52. And when I do that, let's see. 1525 times 52 plus 58, I get 851. So my final answer is she will have $851. Boom. It's not bad. Think about it, y'all. Save $15 a week, 15 and a quarter. And look what happens after a year. Next one. Oh, this one's a little different because it's not a straight segment, and we have a hole here. This graph models Andre's biking over time. Use it to answer the questions. How many days did he track his biking? I'm not going to lie. I might have put the wrong answer on the answer key, but the more that I see this word track, this is how many days did he look at what he did. Now, we know that he traveled for 20 days because he went from day 1 to day 20. But how many did he track? Well, 1, 2, 3, 4. It looks like he tracked 4 of those days. Give the independent and dependent. Once again, remember, independent is always along your horizontal axis. So the Quantity is time. We measure it in days. My dependent is always here. This is my distance biked, and it is measured in miles. Give the domain and the range. Okay, my domain, it's my smallest x-coordinate to my largest x-coordinate. Let me write that up here. My domain, it is my smallest x-coordinate to my largest x-coordinate. Likewise, my range, remember, that's why I've always wanted you to write these in increasing order, because you always start with your smallest and you work your way to your largest. So that's what we're going to do here. For my domain, I go from 1 all the way out to 20. Now notice here, we are less than x, not less than or equal to, because of this open circle. This open circle tells me that it's strictly less than. And then we are less than or equal to 20. So I'm guessing with this guy, he didn't say, all right, it's day 1, let me start tracking. He waited maybe a little bit after he started riding. I don't know. My range, it is my smallest y coordinate to my largest y coordinate. It's my low to my high. So yeah, let's say that. I want to go from low to high, or bottom to top. Let's say bottom to top on a graph. That is so not mathematical, but it's commonsensical to me. So, oh, what a hot mess here. So I want to go on a graph from the bottommost point to the topmost point. So let's go and do the range. Range is leftmost to the rightmost. All right, so let's look at it. My domain, the furthest to the left that I can go is 1, but I do not include 1. The furthest to the right that I go is out to 20. Oh my gosh, I'm so glad I looked that over. The leftmost I go is to 20. So from 1 to 20, there's my domain. Now my range is my height. The bottommost point I have there is 8. And the topmost I have is 28. So we're going to say 8 is less than y, which is less than or equal to 28. Once again, it's strictly less than because we have an open circle. And if I were to show you interval notation, we're going from 1 to 20, exclude the 1, include the 20. So parenthesis, bracket. Same thing here. We're going from 8 to 28. Exclude the 8 by curving it. Include the 28 with a bracket. Give the unit rate the slope with units that models the situation from day 1 to day 5. So I want to go from here to here. So what is my rise? I'm going from 8 to 20. And then my run, I'm going to the right 4. And a lot of you will be able to pick up the triangle. I guess I did there. So my rise, so let's do this. Slope is my rise over my run, which is 12 divided by 4, or 3. So it looks like 3 miles per day. I hope it's not a race. So for those that need the slope formula, we're going to take 20 minus 8, because I'm doing this mainly for me, and then 5 minus 1, 12 divided by 4 is 3. Most people can't look at graphs. Most people is me. I need a formula to help me. Explain in words what is happening on the graph from day 5 to day 7. So it looks like he's traveled 8 miles on day 1. On day 5, he's traveled 20 miles. Now, we can't say he travels -2 miles. Imagine telling somebody that you traveled -2 miles. They're going to look at you like you're dumb. So it looks like this actually measures some distance away from a starting point. So it looks like he traveled 20 miles away from that point, and then he ended up traveling 18 miles away from that point. So it looks like he had to turn around. So it looks like on day 5, he biked back to the starting point. He's returning somewhere for 2 days. Oh my gosh. On day 5, he biked back to the starting point for 2 days. Just out of curiosity, what would happen if the graph went like this? This time is moving on, but his distance is moving on. That would mean maybe he stopped to rest. I don't know. Give the unit rate that models the situation from day 5 to day 7. So it looks like he went down 2 and to the right 2. So -1 mile per day. How'd you get that, Robideer? Well, slope is the rise over the run. Oh my goodness. Let's take this here. Slope is the rise over the run. So that's -2 divided by 2, which is -1. And if you're like me and insistent on using the slope formula, we're going to take 18 minus 20 divided by 7 minus 5. That's -2 divided by 2, which equals -1. Give the domain in hours. So here's the domain in days. How do you convert days into hours? We have to multiply by 24 because there are 24 hours in one day. So 1 day is 24 hours. 20 days is 480 hours. Andre's biking rate from day 7 to day 20 is 10 miles for 13 days. So, we have a slope there, a rate. If he continues to ride at this rate, how many miles will he have biked in a year? So it's starting on day 7. So we want to just focus on the 18. So this is my new starting point. They're basically saying, all right, let's go from here. So again, I love my slope-intercept form. My rate is 10/13. My intercept is 18. So let's find what this is. This is 10/13. Now we're going by days. So in a year, there are 365 days in 1 year. All right, so let's look at this one. I have 10/13 times 365 plus 18. That's 299 point stuff. But let's go ahead and round this up. No, just kidding. It's 298.8 days, which makes this 299 days. There it is. Robideer, why'd you do 10 divided by 13? It's a fraction. Okay. 10 over 13 times 365 plus 18. Remember, y'all, a fraction is a division problem. I need to see, why'd they give me a fraction? Because you put in a fraction, goob. So I want to turn the fraction into a decimal. So I'm going to do that. Boom. 298.76, 299 days. All All right, number 4 has a little trick question built in. So let's see if you notice this. We want to answer the following for the graph provided. So it looks like it's money being earned by somebody. So the number of years you played are graphed with the money earned in millions. Give the independent and dependent quantities. Well, it's time played measured in years versus money earned in millions of, in dollars. What is my domain? My domain goes from left to right. So 1 is less than or equal to x is less than or equal to 5. I go from 1 to 5 inclusive. My range. Okay, my range goes from, there's my low point, there's my high point. So it looks like 10 to 90. But it's not really 10 now. It's 10 million. That's the difference here, to 90 million. And if you don't like the words, you like to see those zeros, there it is. So be very careful when looking at your domain and your range. And we want to give the domain in weeks. Well, that means we have to multiply by 52. 1 times 52 is 52. 5 times 52, 10 is 260. So 52 is less than or equal to x, because domain deals with the x coordinates, is less than or equal to 260. That would look like that. All right, sketch a linear, let me stop. Any questions? Well, that's number 4. All right, now let's look at number 5. Sketch a linear graph. All right, once I see linear, I know I'm making a line here whose domain is between 2 and 12. Include the 12, include the 2, exclude the 12. So we're going to have an open circle at a 2. We're going to have a closed circle at a 12. The range is 5 to 18. So let's do this, 2, 12. The range goes from 5 to 18. Robadeer, why did you write that one vertically? Well, because range deals with the y coordinates, and y coordinates we measure going up or down a graph. So how am I going to make a graph that goes from 2 to 12 on the left horizontally and 5 to 18 vertically? But I have to have an open circle somewhere and a closed circle somewhere. Well, think about it. This is x equals 2 to x equals 12. This is y equals 5 to y equals 18. So if we put our open circles together, it looks like our x is 12 and our y is 5. Well, guess what, guys? That's an ordered pair. Not 5, 12, goob. X is 12, y is 5. Let's look at where we have a closed circle. We'll have a closed circle where x equals 2 and y equals 18. So that's the order pair 218. So let me put a closed circle at 218. Oh, wow. Let me put an open circle at 12.5. I did not anticipate this being a decreasing graph, but if you follow the rules, there it is. All right, let's double check this just to be sure. Domain, how far to the left, how far to the right? Well, from 2 to 12. Include the 2, exclude the 12. Did I cover everything? Yes. Now let's look at range. How low to how high? My lowest point, my lowest y coordinate is 5. My highest y coordinate is 18. I've got an open circle at 5, a closed circle at 18. Do not equal 5, check. Do equal 18, check. So that's my graph. That's not bad. So when we're dealing with graphical analysis, it's not just where is the y coordinate. It's more, okay, you know where the y coordinate is, what does it mean? It's not where are we increasing, what's happening when we're increasing. Are we moving away? Are we moving closer? Are we earning more money? Are we losing money? One thing we did not discuss, well, which I briefly did, was what happens when the graph flattens out? Well, that means that time is moving, but distance isn't, so you're standing still. So keep those things in mind as you work through this.